Welcome to today's webinar. We are very pleased to have with us today Henrik Rext, Performance Engineer at Neotys. Neotys is a leading provider of load testing software. He has been orchestrating and conducting performance tests for over 10 years, delivering projects in all contexts, including large cloud testing on the most demanding business areas such as trading applications, video on demand, and sports websites. Prior to Neotys, Henrik worked as a .NET architect for Logical and performance testing expert on large accounts in a variety of industries, including insurance, car, retail, and energy. Amongst the numerous initiatives he worked on, Henrik has built a performance center of excellence handling load testing of all European branches of a major insurance company. Henrik is joined by our dynatrace speaker, Asad Ali, product specialist at dynatrace. Asad is a technical product evangelist with over 15 years experience in object-oriented programming, databases, and scripting languages. His vast expertise includes application performance for Java, .NET, containers, and mobile. Asad leads a team of technical resources for the dynatrace application monitoring product. His mission is to extend and enhance dynatrace application monitoring capabilities to help adoption of the product in large-scale deployments. Onward to our learning.
Thanks, Ricardo. Good morning, good afternoon, good evening for depending on where you're based. So like mentioned, today we're going to talk about continuous performance testing in monitoring in Agile development. So we'll see how we can include that as an early stage in this process, and also move forward with the DevOps methodology and have a couple of examples. So before we get there, I think it's important that we remind us who we are, who is Neotys, what do we deliver on the market, and then we can move forward with the content. So Neotys is a French company. We are on the market since 12 years now, focusing on one single thing, is helping customers to deliver performance applications. So we started our story in the south of France, so the headquarters is based there, and since then we've grown a lot. So we have offices in the U.S. East Coast and West Coast for the U.S. market, and recently we opened an office in India, in Bangalore, for the Indian market. So the way we are, today we have we have more than 1,800 customers around the globe. We do not focus especially in a specific business branch or business areas. We try to help customers having performance requests. This is the only thing how we answer our market. And the way we are delivering features and delivering new versions of our products is based on the challenges of our customers, and we address them by three main challenges, which is the first one is user demands. I mean, today we'll see that later on user experience has been more than important. I mean, we are having very demanding customers from the moment they start waiting to get content display on their screen. They are becoming very annoying. So people having huge expectations on the performance and the user experience, and if you don't deliver proper application, then it's an impact for the brand, for the revenues, and so on. So as load testing vendors today, it's very important for us to be able to measure user experience. Even if you look at those new framework with complex UI, with a lot of rendering at the client side. So this is one of our main thing we're looking at. The second thing is the process. I mean, our customers 10 years ago were waterfall, and they moved then to Agile, and then slowly to continuous deployment, to continuous delivery, and DevOps. For us as a load testing vendor, it's important that we bring the right features, allowing our customers to include our product in their testing framework to fully automate their testing approach. And you will see that later. I will have a couple of things explaining how we can include load testing within the DevOps Toolchain or the Agile Toolchain. The last is technology. I mean, we have been a technology-driven company. For a load testing vendor, we need to make sure we provide the proper support on the latest technology of the market. I mean, the last 6 years we've been focusing on bringing features around mobile testing, and now with the with the continuous delivery and deployment, we are looking at containerization technology, and we're looking also at real-time technology like WebSocket, HTML5, TP2, and we've been the first one in the market supporting those. And the last is IoT, which is for us a big trend, and we want to be at the first vendor having nice features to help you to qualify your IoT platform. So now you have a fresh idea of who we are and what we deliver in the market. Let's now go to the main content. So let's start by reminding us the importance of performance, especially in the user experience. So here I have I'm just highlighting the fact that user experience is important because most of our users today, they are utilizing their phone to access to our applications. So it means they can connect to our applications during working hours, during nightly hours, so we have more spikes during the entire day. Second thing is the performance aspects. If the users start to have really bad experience on your applications, then the first thing they're doing, they're removing the applications, or they're going directly to the computation to reach the same content. And the last is the way people are connected today. Everyone has social networks, social medias. From the moment they are experiencing some really bad user experience, the first reaction is to share that feelings on the social networks. So we have to make sure that we deliver proper performance to avoid having an impact on our brand. We are talking since the beginning on user experience. I think it's important for us to remind us what is user experience. I mean, user experience, in fact, is a combination of several things. The first thing, I mean, the core element of that is a feature. I mean, if you don't have a feature, then you don't have any experience. So you need at least a feature on the application, and that feature needs to work. So functionality is the key. Then on top of that, add some ergonomy. So we need to have a really nice design, very easy to use, very intuitive, so people don't have to find or have the documentation nearby their table to start using your application. And last is performance. I mean, does it make sense to have the nicest applications, having a lot of features, but you have to wait 2 or 30 seconds between each click? You will be probably very annoyed. So user experience is a combination of all those layers. In fact, what is important, very interesting here, is the impact of user experience on the business. In here, I have extracted 4 references from a website called wpostats.org. I could add probably several of those, but the main thing here is just align with one of the oldest study done by Amazon. In fact, it's almost 10 years old now. This study proved at that time, Amazon proved that every time they were increasing the response times on their websites, they were losing 1% of revenue, and which is very interesting if you look at those different references, like starting by Etam, which is a French retailer. Every time they have optimized the websites, moving from 1.2 seconds to 500 milliseconds, they simply increase the conversion rates, the number of page viewed, the number of visits. So the entire business has an impact with this optimization. The second is Walmart. If you see here, the increase every 100 milliseconds improvement is an increase of 1% of revenue. It's very funny. It's really the same numbers Amazon has provided. So we know that for sure user experience is important and an impact the business for sure. But also it's quite stressful performance. I mean, if you go to a restaurant and you order food but you never served, you probably quite being very annoyed and frustrated, and the natural reaction is to leave a message like this. I mean, we won't probably use ketchup and mustard for do that, but that will be one of the reaction of our users. So user experience is a key element. So we know for sure that we will have to validate to reduce the risks before going live in our production environment. And we have changed the methodology by implementing Agile to be more focused on our customers and bringing more features. And what does it impact load testing? In fact, the interesting thing is to see how we used to do load testing 10 years ago, and I like to compare that with video games called Street Fighter. So just for those who are not aware of that game, you could Google it, of course, but the principle of it is there were two fighters fighting to each other. They had 3 rounds to win, and you were moving by crossing different fighters. And between those different fights, you had that bonus stage. And performance testing was a little bit like that bonus stage, in fact. So sometimes you had it, and sometimes you didn't have it. So it was not mandatory between each fight, it was optional. Exactly like load testing. Sometimes you needed to do it, sometimes you did not. And the way the bonus stages were working, you had that car finalized, shipped, very shiny, came out from the factory, and exactly like the product we were testing. We were waiting that everything were configured, assembled to start launching our tests. So we needed the car, so the car will be the application. So that was a last mile testing sort of before going live. And then the tester, what he did, sometimes he didn't have a proper methodology. So the only thing he was doing, it was exactly like that fighter. He was generating hits. He was hitting the car to break it. But what did he prove except filling in an Excel sheet saying, yes, I did the tests, I've done it, I'm very happy, but what did you prove? When you test something, you're proving that your application is able to support a specific situation. The second story is about the Tacoma Narrow Bridge, and that will prove the importance of performance design, in fact. The thing about it, the Tacoma Narrow Bridge, the story about it, for those who is not aware, it's a bridge located nearby the Washington area. It opened in April 1940 and it collapsed 3 months later. And the really interesting story related to performance is that they had tested that bridge, in fact. They had, in the architect knew at that time that they had 2 main constraints. The first was the load, the capacity of handle a large number of cars on that bridge, and the second one was the ability of supporting strong winds. So they did 2 tests. One day there was no wind at all. They were loading the bridge with the car and trucks, took some measurements, and at the end of the day, he said, yes, it works fine. We support lots of cars. We support load, so we made them make that checkbox on the Excel sheet, said, yes, we can go further. Load is respected. Then they had that second constraint. So the ability of supporting wind. And for that, they were waiting for a very strong day, windy day. Obviously, they didn't load the bridge with cars, so the bridge were empty. They took some measurements, and the bridge was not reacting at all against the wind, so it proved that it was supporting wind. And what happened the day it collapsed? It was simply the combination of load plus the wind that makes that bridge collapse. And it's the same thing with your applications. When you test something, you need to have every constraints in your test. Otherwise, you will probably say, hey, it works fine, you can go to production, but maybe you forgot just the wind. So it's important to understand what you're going to test and how you're going to test it. And there was a workflow when we used to do load testing at the pre-production or the last mile or whatever it is, and it's always the same steps. The first one is strategy, figure out what kind of test I need to run to reduce the risks of performance in my production. What type of scenarios, what are the main actions, what is the load policy, how many users. Once we had that strategy, we can go to the next step, which was creating the scenarios. Do that we were recording with the load testing solutions, correlating by adding lots of variables, data sets, because here obviously I don't want to do just record playback because I'm not going to qualify the cache because for sure I know that my cache is working well. Next, I prepare, so means deploy. I prepare my database with data sets, and I implement the monitoring. Remember, load testing without monitoring is not meaningful. I mean, it's exactly like listening to a horror movie on the radio. You will hear people scream, but you don't know why they're screaming. You need that full picture. You need to understand what happens to which actress and so on. So it's the same thing with load testing. When you run load tests, you need to have the full picture, understand what's happening in your system. So set up AppMon here will be very useful. Set up the proper monitoring of the infrastructure will be useful because you're fishing for problems, you're fishing for metrics. So then we're going to execute. So we're going to run each test that we have planned, analyze them, and probably do some tunings. Two levels of tunings. One is purely on configuration or making some minor changing on the architecture by adding more or less caching layers or more or less nodes and so on, pre-review the configuration of the web servers, application servers. And then if it's the code, then you need to point out what level of code is the bottleneck. So dynatrace with a pure path will help you to figure out which layer is the problem. And then you can give that information to the coders and change the version of the application. So this approach is still meaningful, but still it needs to have the application ready, like the car in Street Fighter. We need to have that shiny car. And here we want to test that in a very early stage. So how do we do that? So it's very simple. First, we need to include performance as a risks. So measure which risks and how we can reduce the risk before going live by implementing the proper tests. We have to understand the application to implement the proper strategy, and then we're going to run tests on daily basis. So doing it manually like the old-fashioned days, it won't help us. It would just be a blocking point, just be a bottleneck for the process, for the project, so it would be just a damage. So we need to automate. Automate is the key. We're going to run tests on daily basis, and the idea is to figure out regressions. And to be able to figure out regressions or trend, we need KPI. So we need to validate those KPI, identify those KPI that will help us to trend and figure out regressions. And last, we have the green light. We deploy our application in production. We need to detect problems before our users by implementing a proactive monitoring. With the help of dynatrace, with the user experience measurements, the synthetic AppMon, you will have that advantage to have all the information to feed your backlog. So let's go on those steps. So first we have to understand the application. So we need to figure out where is the load coming from. Is it the user? Is it a third-party system? Is it only desktop user or mobile users? Is it some messages coming in the systems? So our IT is very complex. So we need to figure out where does the noise come from. Then we need to ask us the proper questions to figure out what type of tests I need to run to secure my deployment. How the user is working on my systems. For example, if all my users are at 9 a.m., so everyone connects, maybe to take a coffee afterward, and then start working. So maybe you have huge logging, a large number of sessions at 9 a.m., and then we will starting having transactions. So that may be my first requirement, is to validate that I am able to support those sessions. What are the habits? Where and how often? Are we going to expand to several geos that will probably have some specific situations or impact more network constraints? Do I have any marketing plan to promote that will bring some spikes? So I need to understand those aspects. Then that will help me to figure out which test I'm going to run, which load. Then I need to figure out which testing scenarios, which use case, and what are the numbers in front, what are the number of transactions per second or per hour or whatever it is I need to run on my environment. So I have two types of applications: historical ones where I have good knowledge because it's been in production for decades, so I can take advantage of the information stored in database and the logs. I probably have some user experience measurement solutions or tracking solutions like Google Analytics where I can take advantage of that to build up my load policy. Our new application is different. I don't know where I'm going. It's science, pure science fiction. So I need to explore, see how it behaves under load, do some capacity planning. But also, if we have invested so many money here on this application, there is probably a reason. So someone has numbers. So let's at least figure out how that application behaves with those numbers. So we want to test as early as possible. So we are not going to wait that everything is assembled to start testing. So for that, we're going to implement unit performance testing or component testing or API testing. There is a different word for that. The advantage of that is you don't have to wait that the system is assembled. You can start testing right away. You have a component ready, you can start testing it. The second advantage is the test case. They are very simple. Couple of variables, couple of API calls, and so on. And if you are a microservice application, it's even better. The APIs, the interface of the APIs doesn't change every day, so it means one scenario is probably that you've created will be stable until the end of the process. And last is third-party components. If you add components, you buy third-party components, don't trust the numbers provided by the vendors because they have testing on your lab. This lab is not your IT environment, it's not your network, it's not connected to other systems, it's not the operating systems or the servers or the VMware or whatever it is you have there. So these components will probably behave differently when you plug it in your environment. So start testing it before discovering that all your bottlenecks is related to that component. So how do that work? To do that, you have to change mentality. We used to do late record playback performance testing. Now we're going to implement the early performance engineering. We used to set up SLAs based on business response times. Now we're going to convert that into component level requirements. So we used to do black box testing without knowing very what was inside of our application. Now we will have a fresh idea of what's behind our application. So it's going to be gray box testing. So the process is simple. So first, you need to specify which use case is meaningful. So if I take e-commerce websites, I will probably search, browse, view some products, add them to the cart and pay them. Then once I have those use cases, I will translate them into components in order to highlight which components are very important for my application. Which component is the heart, the hands, the feet, the brain of my application. And those components, I will test them on a daily basis. Then I plan the sprints. So because we are in Agile, we will have several sprints. In each sprint, we'll add more and more features from the backlog, and then we have a release. So once we plan the sprints, we have a pretty good idea on when those components will be available. So here, for example, I have three important components: the red, the gray, and the blue one. So the first component is the red one. So either the performance engineer or the developers implement the component tests. So one API call or two API calls, include that in the building process, which means on the first sprint I will have at the end of my building process, one load testing on that component. And I will trend the results on daily basis. Then, second component arrives, I add a new test for that component, so it means I will have 2 tests running on my building process. And then the third one arrives, I will have 3 component tests after my building process, which means every day I will be able to trend how those components react under load, trend the KPIs, and detect regressions. Once everything is assembled, I interconnect those components together. It means I have a meaningful business case. I can start testing the business case from the UI to make sure that I don't have any regressions or strange behavior once those components start discussing to each other. So here it's more the continuous performance validation approach that we recommend as a load testing vendor, where you have the backlog. This is where you're going to have the performance qualification. You plan the sprints. This is where you're going to do component testing on daily basis triggered by Jenkins or Bamboo or your favorite CI server. This will be connected with dynatrace to get some relevant information on which layer is the bottleneck of your application. Then once you have the application assembled and deployed on a more representative environment, we will do some tests, focus more on the end user experience by testing the UI, the mobile application, or generating load from the cloud, for example. And then once we have all the green light, we can go to the production environment and implement the proper monitoring on the application. So that gives a good idea on how you're going to implement the load testing in Agile by testing the components and then focus on the UI. And what about DevOps? I mean, most of the organization has adopted Agile development methodology, and from the World Quality Report 2016-17, it seems that 88% of the CIOs are now using DevOps, and more companies are going to move to DevOps to be able to deploy more releases and more focus on customers. It's not because you're deploying more and having more you're implementing speed on the process that you cannot deliver proper quality. I mean, speed is nothing without quality. It's not because you have the best car in the world, then if you don't know how to drive it, then it's going to just be a mess. And it's the same thing with software, with application, with websites. If you have a lot of releases, you need to make sure that the quality behind that are still acceptable and you don't impact your user experience. And the thing also is, people say DevOps, and I've heard people or a couple of organizations saying, I moved to DevOps, I have removed the QA, the Ops, and now I'm fully DevOps. That's not the real thing. I think behind DevOps, we have Dev, Test, and Ops. In fact, it's the frontier between those 3 silos that used to be silos, that's not as silos anymore. So Dev, QA, and Ops is a single team now. So we need to figure out that we are testing. And in fact, a good example is having highlight that with the DevOps pipeline, where today, I mean, people talk about Agile Toolchain, DevOps Toolchain, but what is a DevOps Toolchain? In fact, it's the way where you start connecting different products to have a fully automated platform. Where you can automate your tests, deployment, and so on. And there are several families of solutions. First, you need the planning solutions, where you're going to affect tasks, plan them, have a really make the information visible from all the stakeholders. Then you have a source control, because you need to track the code, the change of the code. So that's new. We used to do it since decade. So but now we're going to also track the change on the infrastructure, the configuration, the deployment, and so on. We test as well. Then we're going to have the configuration management. So it's not the way we're going to deploy the application on dev or QA or pre-production is not the same, because in dev, probably in pre-production, we have more servers, bigger database. So the configuration management is totally dependent on the environment and where we're going to deploy it. So this configuration needs to be handled like a code, and this is going to be stored in the source control. The CI server is the main component. He's going to orchestrate everything on our pipeline. So we need one CI server. That's the good start. Then we're going to deploy. So we have, depending on where we're going to deploy, in production or dev or whatever it is, maybe we deploy in the cloud or in containers or in virtual environments. It really depends where we deploy. So we need deployment tools. And like mentioned, DevOps, we need to test. So we need testing solutions, include that within our pipeline. And last is APM. We need to monitor each environment and of course our production environments to make sure that we measure the proper user experience of our customers. So let's have an example. So step one is the build. So we have here a coder. He's looked at Jira, so that will be the planning solutions. He has a task. He needs to make some change on the environment, on the application. So he starts implementing the code. Commit the code in Git. So Git will be the source control. And then we have Jenkins in the top here. And Jenkins detect, we have configured Jenkins to start a build from the moment there's a change. So you detect that change and prepare the build. So preparing the build means retrieve all the latest version of my application by doing a checkout in Git, compile the code, and package the code to publish them maybe in Nexus, for example. Stage two, we're going to deploy. So here, depending on which step we are, dev or QA or pre-production, we're going to grab the configuration management script available in the source control, so it could be a Puppet or Chef script, and we will deploy in the proper environment. So if we deploy in dev, I will check the Puppet script of dev, for example, and then I will start deploying by using deployment tools. So I could deploy in containers or in the cloud or wherever it is. So I can use technology such as Docker, OpenShift, OpenStack, and so on. Then step number three will be testing. So I have a full stack of tests here. Depending on the environment, I will have more or less tests, of course. And I will have first integration tests, so we can call them white box testing because we're really nearby the code. Then we will implement the functional testing. Could be Selenium or Perfecto if you have a mobile application. And then you have the green lights of this step. You can move to the next step, which is performance. And we will probably migrate scenarios in functionals to have them available for performance, and we're going to launch a test with Neoload for performance testing, either a component or system-wide testing directly with Neoload. Next is security. So we can test SQL injections or port mapping. But the most important thing is to have visibility for all the stakeholders. So each test you run, we need to send the feedback back to Jira to say what has been passed and what has been failed. Last is release. So once we have the green lights on dev, QA, pre-production, we have done all the tests that we have planned, then we can release in production. So take the Puppet script or Chef script related to our production environment and start deploying it. And also we're going to make sure that our monitoring is also aligned with the new versions, that all the agents has been deployed on dynatrace, and that we are measuring the user experience of our users. So that gives a pretty good example of a DevOps pipeline. Of course, there's no fixed pipeline. It really depends on your own process. The idea of a pipeline is more built through code. So the pipeline itself could be stored in your source control, and Jenkins grab it so it means you're continuously involving that pipeline depending on the project that will be probably enhanced during the time. So before we finalize this webinar, I think we've talked about connecting Neoload with dynatrace. So why do we have to combine load testing with dynatrace? There is one simple reason. When you go to load testing solutions like Neoload, you will measure response times, infrastructure of the behavior of the infrastructure because we have monitoring like operating systems, web servers, database, application servers, but we don't never go deep to the code, which means if we see that we have something, an alert or the response time start to be very high, we won't be able to point out what the exceptions or which layer has spent a lot of times. So by having the pure path here, you will have lots of advantage and you will save a lot of time. So how does our integration work? So first, you have an application. So I have an example with 3 layers application, presentation, business, and database. On all those architecture have deployed some dynatrace agents, and those of course are connected to my dynatrace server. Then I need Neoload, so I've prepared a Neoload project with scenarios, and here Neoload will generate the load. The first new thing that Neoload will do here is to send tags to dynatrace. So those tags will help you to detect the traffic. So our traffic coming from Neoload will be detected like a synthetic traffic in dynatrace. The second aspect is the fact that we are using the session recording API from dynatrace, which means we are able to start a session, stop a session at the end of the test, which means you will find exactly the information related to your test because they will be separately stored. For each test started by Neoload, you will have a dedicated session stored in dynatrace. And if you do automation with Neoload, for example, you will take advantage of one of their really cool feature provided by dynatrace, which is the session comparison. So you will be able to detect if you have any regressions or if you have resolved that regressions, if you have spent less time expected on that specific layer. So before I pass the content to Assad, let's have a short call for actions. So first, I will recommend to start load testing with Neoload. So you can download, we have a freemium version on our website, so you can start downloading it. This freemium version includes the integration with dynatrace. You can have a try. Here, of course, we don't have the time to do a demonstration, but I will be very pleased to do it. So if you need any demo or dedicated workshop, please contact us and we'll be very welcome. We'll be very pleased to organize that type of session. So I said, I think you want to go deeper on dynatrace, so I will let you present those aspects.
Thank you, Henrik. So I'm going to start a little bit of introduction of dynatrace. As Henrik mentioned earlier on, digital performance of your end user is very, very key, and same is true for dynatrace. We strongly believe in providing insight into you to provide the best digital experience to your end users. As we look at the end users right now, they're using a real browser, they're using mobile devices, and they're using it from different parts of the world. As well as these customers and these users really don't care what kind of infrastructure you're running in the back. But we see a lot of our customers and the prospects are now shifting towards cloud through Docker monitoring, containers, and ultimately they're using databases, SQL and NoSQL database in the back to really capture and persist all the data. So with the dynatrace full track, broad and hyperscale monitoring, you get end-to-end monitoring of your end users from the browser all the way into every tier, every method that is being executed on the back end, and then including all the SQL calls into your databases. So dynatrace provides end-to-end visibility to your application as well as any third-party calls that you're making from your application. Now, when you look at end-user performance, there are factors that come into picture. So you may have a web application that is running Java, .NET, could be deployed on Node or PHP. You could also have applications that are third-party applications like SAP, PeopleSoft, that are native applications. They do not allow any agents to be injected. And then you also have applications deployed in the cloud and the containers. So talking about the synthetic monitoring, the dynatrace synthetic monitoring allows you to really test your application from any part of the world, including using the real browsers, using mobile devices, last mile, just to ensure that anytime you release a new code to your end users, you can use the synthetic monitoring to make sure that the new code looks good and it performs perfectly before your real users uses your application. When I look at synthetic monitoring, also I look at it as a kosher environment for me to test my application. A lot of real users would be running multiple applications on their laptops or their mobile devices. They would have many different tabs on their browser that could affect performance. With synthetic monitoring, you can really compare synthetic monitoring data with the real user data and see whether the poor performance that is affected to an end user is really caused by your application, or is it an environmental issue that is causing it. And then when you compare the end user performance with synthetic performance, you can quickly decipher what is causing the problem. And of course, you can define alerts and incidents so that you can take proactive notification if the synthetic monitoring is showing a poor response for your web application. As I mentioned before, you also have, a lot of our customers have native applications provided by third party like SAP and SAP Citrix, PeopleSoft, and these applications do not allow any agents to be injected in them to look at the performance of these applications. For that, Dynatrace has Agentless Monitoring, where we are able to look into your network, pick up the packets, analyze the packets. The DCRM product from Dynatrace allows you to look at this packet, have the special decodes to decipher the data in these packets, and be able to tell you where the real performance is going on and which users are affected in these third-party native applications. Now, besides this, you also, as I mentioned earlier on, a lot of customers are now moving to containers, moving to cloud. And the beauty of this environment is that you're deploying much more faster, much more continuously, as well as it allows, these kind of environments allow you to really scale up and scale down with a click of a button. So with Dynatrace, agent-based technology allows you to easily inject the agent into this dynamic environment and show you what we call as a smartscape, which automatically shows you how many data centers are being involved in your environment, how many hosts are running these applications, and the process level, service level, and at the application level. The whole stack information is available to you out of the box. This whole smartscape is built automatically by Dynatrace for you. Now, when you look at these dynamic environments, of course, the biggest challenge for performance management is there are so many moving parts. There are so many nodes that it becomes humanly impossible to decipher the data and find out the root cause. And for that is agent-based technology allows you to, has the capability to have artificial intelligence in it. So the Dynatrace agent-based technology has artificial intelligence in it, and by doing that is able to go through millions and billions of data points in your application and able to quickly bubble it up to a problem and identify what problem is happening in your environment, whether that problem is affecting your end users or not, and really specify exactly where the problem is so that you can focus your attention to that and quickly find the root cause. And as I mentioned before, when you have a very dynamic environment, where you have thousands or multiple thousands of nodes, you want to know whether if some nodes are down, whether it is affecting your end users or not. In this example, we definitely see some red dots that are down, but ultimately when you look at the smartscape view on the Dynatrace agent-based technology, it tells you that yes, some of the services are affected, but the applications are still looking healthy and end users are not getting affected. So this is the kind of insight you want to know in a very dynamic environment like cloud and in Docker and container-based technology. And of course, as I mentioned, I started to talk about the user experience management. That's also the key here. Dynatrace agent-based technology allows you to know where your real users are coming from, what bandwidth they're coming from, what browser they are using, where are they landing into your page, which is the exit page. if a user is complaining on the social media, as Henrik mentioned a couple of examples in his presentation, you want to quickly find out who the user is and what exact user actions did they do. So that is, the agent-based technology allows you to really get deeper insight into that. So geolocation, what kind of devices the users are using, and also the top X analysis so that you can find out what the top pages, top exist pages, and also lastly you should be able to identify and search by a single user. And of course, with all this data available there, that is agent-based technology allows you to really go deeper from a developer point of view to be able to look at each method, where the time is spent in the method, the whole stack is across all the tier. That is agent-based technology allows you to do that. So having done that, and Henrik talked about towards the end of his presentation about the tight integration of load testing tool and dynatrace. And the idea behind our philosophy in that is that it's not about just blindly automating your CI/CD environment. Of course, you need to automate it. But if you're not able to measure performance at every stage of your application building, what you're ultimately doing is you're pushing bad or poor performance code through your pipeline faster into production. That's why you need ability to get insight as the developer checks in the code, and as it goes through QA and ultimately into production. You really want ability to measure it, and if needed, pull the build out in case it is not performing up to the SLAs. Also, the days are gone where you could just, developers could just not take ownership. Oh, that it works in my developer environment is a production issue now, not my issue. Gone are those days, because now in the dev test ops that Henrik talked about, developer and testing are taking ownership of making sure that the application runs properly in the production environment. So let me give an example of that, right? So suppose you have you did a build number 17, and you have two test cases for that, test purchase and test search. So when you ran through that build, everything looks good, the status came out okay. Then build number 18 was done, but immediately the test failed. The test purchase failed. Then you, because the load testing tool told you immediately that the test purchase is taking longer time, and then you mark it as a failed build. And then you find the regression and you fix it in build number 19. But when you look at the data this way, you need more than this to really find out really whether when the build is really working or not working, what's going behind the scene. You need that insight, and that's where the dynatrace agent-based technology helps you do that. So let's go behind the scene and see what's going on. When build number 17 was made, you could, with dynatrace agent-based technology, you can say, you can find out how many SQL statements were made for in test purchase and how many exceptions were there. And also you get the CPU information, how much CPU time was spent executing those two test cases. So with the test purchase, there was 12 SQL statements, and with test search, there were 3 SQL statements. And when the build 18 failed, what really happened? And the reason the load testing tool like new load is able to tell you that the build failed is because number of exceptions have gone up from 0 to 5. So combination of new load and dynatrace allows you to not only get a good load testing, but also be able to get insights into why the test failed and which kind of transactions failed. So in this case, we immediately know that the test purchase failed because the number of exceptions jumped to 5. And then also when build number 19 was pushed, even though the performance point of view and the load testing point of view, it may look good, if you look behind the scene using dynatrace, you can immediately find out that this build really just should not be pushed into QA, because somebody has checked in a code that is now making a lot more database calls, like 75 SQL calls instead of 12. And if this goes into production, even though the performance of this may look good on a development environment, you surely know that with 35 SQL statements in production is going to take a long time. So having this insight behind the scene with new load and dynatrace together, you get a full confidence that the functional and performance testing is done well before you push the code into production. And when we integrate tightly with a load testing tool, we have a dedicated view where we automatically baseline your test, and whenever some test fails, you can immediately tell why it failed, and dynatrace can alert you saying that this test has failed. So you get to see every REST API tail test, you get to see every UI test, load testing test. All of them are automatically categorized by dynatrace, and then it's able to tell you exactly where the test failed. And here, some architecture changes. You're getting all the architecture metrics here, and then also in this example on the right-hand side, lower right-hand side, you can see that there's a regression happen because the response time has gone above the threshold or the baseline that dynatrace has calculated for you. And also dynatrace provides easy view to look at all your different builds and the performance of every build in a graphical way. Additionally, you can use the dynatrace REST API to pull the data from dynatrace into your CI/CD tools like Jenkins. You can also integrate tightly with Neoload. Neoload is using all the REST API that is available from dynatrace to pull the data and show it to you. So it's very tightly integrated with dynatrace. So the bottom line is that by having this load testing tool integration with dynatrace, you're able to see performance at every stage of your application deployment. And by doing so, you are ensuring that when the code goes from development into different stages, that is, every good performing code is going through the pipeline and it performs well in production environment. So you can use you can download the free trial of dynatrace from our site. It allows for the full stack availability and performance monitoring. It has smart analysis and alerting. As I mentioned before, this is powered by artificial intelligence. And you can also, especially in a cloud environment, in a container environment, it's almost like dropping a file and everything else is taken care for you. You do not have to make configuration changes. The agent is smart enough and automatically injects in your environment. So there's no code change required for this at all. With that, Ricardo, back to you.
Thank you, Henrik, and Assad, for a lively discussion. There have been a lot of questions that have come in from an audience, and I know we won't be able to get all of them, but let's start with a few. Henrik, at which point in the life cycle do you perform end-to-end testing in relation to the component testing that you are already doing every day?
So the component testing is purely at the dev environment. It's more an activity that you could, the developer can do directly. From the moment you get an API, you can start testing directly on his server. So of course the SLAs on the API will be different from one environment to another. So you need first to define the proper SLAs on that environment. The end-to-end testing is more from the moment you have the application assembled. So if you start having an UI available with all the components behind that connected, then you can start doing the end-to-end testing by utilizing the browser and utilizing the mobile device and testing from the cloud, for example. So this is more about testing and validating the user experience, while the other is more securing and trending the performance of the component or the development that has been done on the different releases.
Thank you. Assad, how can we integrate dynatrace with our continuous integration process? Is there any guidance available on the integration part?
Yes. So as part of dynatrace solution, we integrate tightly with Maven and with Ant. So if you're running Jenkins or Bamboo, typically what you would do is you would check, as Henrik mentioned earlier, you'll check out the code and then you will run through your Maven script. As part of that process, typically in a Java environment, for example, you would run Maven and then you will launch your JUnit test. At that time, dynatrace can integrate tightly with your JUnit test and be able to identify each test, and it show you the performance of that test compared to the previous test that you have done. So there is a tight integration available at Maven and Ant level.
Thank you. For Henrik and Assad, if you would be able to comment, what is there to know about how to monitor Docker using this technology?
I mean, Docker could be monitored directly through, there is a different command line on Linux to do that. It's important to monitor because there is a small override on that. I think, Assad, if I'm not wrong, you have something around that topic?
Yes, absolutely. So you're absolutely right, Henrik. Docker is, as I mentioned earlier, Docker is becoming very popular. So you want to make sure that you not only monitor individual containers, but you also want to make sure that the resources you have defined to each container is sufficient to manage your process. So with dynatrace, we have out-of-the-box solution where you drop in an agent file on the Docker host machine, and it will automatically monitor all your container on that host without you needing to changing your image file. It does it automatically for you, and then you can find out how many instances of Docker containers are running across how many hosts, and when you scale up and scale down, you can look at the data with a dynatrace solution.
Once again, thank you very much, Henrik and Assad, for taking the time to share with your experience and thoughts with us.